Good day, viewers. You are welcome. How to solve these nice functional equations? We have f of n plus 3 equals n squared plus 6n plus 9. I want to find f of n given this function. So we are going to be solving this using two different methods. And for the first method, let's call this one method 1. The function says f of n plus 3 equals n squared plus 6n plus 9. So the n here is a member of real number. That is, when we start from the right hand side here, n squared plus 6n plus 9 is a quadratic because of this power of n. And the domain is given as n plus 3 here. So let's try and apply the form manipulation method. But to do that, we have to factor this out. So we know that the middle term here is the sum, and while this one is the product. So we look for two numbers that the sum will be 6 and the product will be 9. So let's consider 3. So 3 plus 3, that gives us 6, and 3 multiplied by 3, that gives us 9. So we go for 3 and 3, and this one becomes n squared plus. We try and replace this 6 with 3n plus 3n. So 3n plus 3n, it gives us 6n. But this is not having n. It means we are going to leave the 9 like that, because 3 times 3, that is 9. After having this, we are going to have n squared, so we pair it with 3n. Then we are going to have 3n also, we pair it with 9. So therefore, we have f of n plus 3 equals, let's factor this out. What is common here is n. By taking out n, we divide this n squared by n. That is n plus, divide 3n by n, that is 3. Then plus also this one, we have, by taking out 3 from here, we are left with n plus, divide 9 by 3, that is 3. And looking at this looks like a perfect square, because this is n plus 3, n plus 3. And we combine their coefficient as well. This also becomes n plus 3. And take one of these, this is n plus 3. When we multiply n plus 3 together, we have it as n plus 3 all raised to the power of 2. And this gives us f of n plus 3. This makes sense? So after having this, we are now going to replace this n plus 3 with n, since we need to find f of n here, and here is n plus 3. So therefore, we are going to have f of n, this equals n squared. So this is the result for f of n, which gives n squared. So let's try and apply another method to solve this and see which one is much more effective. For the second method, so call this method 2. We are going to apply the substitution method here. We say the domain of this equation is given as n plus 3. Then suppose we let n plus 3 here equals another letter, says t. If you make n plus 3 equals to t, then By making n the subject of the formula here, let's subtract 3 from both sides. So plus 3 minus 3 cancelled, and here we have n equals t minus 3. And from this quadratic term here, we have n squared, we have 6n, and we have 9. It means that from here we need n squared. To get n squared, it means we take the square on both sides. Here we have n squared equals t minus 3 all squared. And by expanding this one out, we are going to have multiplying this one in 2 times, that is t minus 3 multiplied by t minus 3. And t times t, that is t squared, minus t times 3 minus 3t minus t times 3 times t, that is minus 3t, minus 3 times minus 3, that is plus 9. And the whole of this one becomes t squared minus 3 minus 3, that is minus 6t, then plus 9. This is for n squared. And out of this term as well, we also have 6n. For our 6n, it means we multiply 6 with what we have there, which is t minus 3. Then 6 times t, that gives us 6t minus 6 times 3, that is 18. Then we also have 9, and that one is just like a constant term there, so we have to leave that one like that. Therefore, we come back to the function, which is f of n plus 3, which gives n squared plus 6n plus 9. But n plus 3 here has been let above to be t. Therefore, we have f of t equals, so n squared here is given as t squared minus 6t plus 9. And for our 6n, this gives us 6t minus 18. Then the last part here, which is plus 9. Looking at this one together, we have t squared only. Here we have minus 6t, and here is plus 6t. They cancelled. Here we have plus 8 plus 9 plus 9 minus 18 also cancelled, which means we only have t squared here. And this is the result of f of t. Then by changing t to n, we there have our f of n, which gives us the result that we got above. As by replacing t with n, we have f of n equals to n squared. So this is how we solve this problem in 2 different methods. Thanks for watching, and don't forget to subscribe to this channel. See you in the next video. Never stop learning. Bye bye.